Alrighty, here's part 2 of our partial fractions lesson and demonstrations. If you didn't notice in part 1, there was a mistake that I made. So the first person who can email me the mistake that I made, I'm going to give you a bonus point. So feel free to go after some bonus point, folks. Who found that mistake? I laughed at myself when I went back and reviewed it and watched myself. So anyways, part 2. Now, before, our denominators were linear factors. They were distinct linear factors. In this case, we're going to have quadratic factors. Now, this is a prime quadratic because notice it can't be factored. What times itself will give us 4 but add up to be a 2? It's not going to happen in this case. We're not going to be able to factor it with our 1 for the front part there. So we have a linear factor and a quadratic factor. The other thing I want to point out for you folks to notice is that this will work when our numerator's degree 2 is smaller than our denominator's degree, which if you multiply this out, notice we'd get an x times x squared, which would give us 2x to the cube. In this example over here, we would actually have x to the 4th, and that's an x to the 3rd, so the numerator, again, is a smaller degree than the denominator. So the difference between these two is this has one distinct prime quadratic factor in the denominator, as well as a linear one. But over here, we have a repeating one. Kind of like, remember that second example we did in the first one, when we had repeats, we had to do it to the first power and to the second power, have as many powers as there were. This will be just 2, a first power and a second power. We'll get to that in a few minutes. So over to this problem. There is one little difference here. We are again going to have, we're breaking it up into a fraction plus a fraction. But in this case, notice, so we have the denominator here that's linear. So like our last time, our denominator here, x minus 2, its numerator is going to be a, just like we had done in the last time, because that's just like the last time. It's a linear denominator, so we've got a constant numerator. However, when we do the quadratic denominator, which we're going to put down here, x squared plus 2x plus 4, when we have a quadratic denominator, our numerator is going to be a linear numerator. So we have to go to the next variable, b, but it's going to be bx plus the next variable, c. So notice mx plus b, that's a linear form right there. So this is linear over a quadratic. This is constant over a linear. Okay, now, like the last time, we're going to clear the fractions out. So we're going to multiply both sides by the common denominator. And the common denominator in this case is literally the x minus 2 times the x squared plus 2x plus 4. So let me reach on over here. And over here we're going to do that. X minus 2 times x squared plus 2x. What is that? Plus 4? And all that's going to cancel, right? Cancel, cancels, cancels, cancels. That's pretty lovely. We like when that happens. Over here, we're going to multiply this whole thing by the same thing, x minus 2 times x squared plus 2x plus 4. That parenthesis there. And so then, when we go ahead and distribute this here, you'll notice the x minus 2's cancel. So we're left with a times the x squared plus 2x plus 4. Close that. When we distribute this into the bx plus c, notice the x squared plus 2x plus 4 cancels, and we'd be left with the x minus 2. So we're going to put plus bx plus c times the x minus 2. Now, of course, that's all still equal to this over here, 3x squared plus 17x plus 14. Now, we have to simplify like before, and we're going to solve it. And that's basically what's going to happen now. So here I'm going to distribute in the a, and I still get my 3x squared plus 17x plus 14 equals ax squared plus 2ax plus 4a. And then here we're going to FOIL. So first, there's bx squared. Outer minus 2bx. Inner plus cx. Last minus 2c. Okay. Now, let's try this guy for a second. Like before, we're going to combine our x squareds, then our x's, and then our constants. And it's still going to equal this. So let's write that out. 3x squared, 17x plus 14 equals. Now, ax squared plus bx squared. Those are the two x squareds. Now the x's plus 2ax minus 2bx plus cx. And now the constants. Plus 4a. What is it? Minus 2c. Okay. Now, this part, we're going to factor the x squared out like we had done before. So if I take x squared out, I'm left with a plus b. This part, we're going to take the x out. So plus 2a minus 2b plus c, all of those times x's. So we had our x squared here. We have our x to the first there, if you will. We take an x to the 0 out. That was like that constants one we had talked about before. So say plus 4a minus 2c. Let's put that in parentheses as well. What does that all equal? Well, that all equals this stuff still. 3x squared plus 17x plus 14. So what do we do with this? Well, we realize the 3 equals the a plus b. So here we go with our linear system of equations. A plus b equals 3. That's not a minus, that's a mess up on the board. 17 equals this part. 2a minus 2b plus c equals 17. And then finally, the 14 equals that part, 2a minus 2c. Now, we have a system of equations again. We can solve it with substitution. We can solve it with elimination by hand, or we can use our calculator like I mentioned in the last video. If you know how to do this with matrices, you're welcome to do that. But if I recall from Algebra 2, you guys had learned how to do this with reduced row echelon form in the calculator, or otherwise known as RREF. So how did we set that up? Well, in our calculator, remember, turn that on. And inside of it, what you're going to do is you're going to go to the, oh gosh, we want to go to RREF, right? So I'm going to do second catalog. And then from second catalog, I want to go to the R's. So I can either go to the R's and scroll down, or I'm going to go to the S's and scroll up, because it's faster to get there that way. So I get to RREF, there it is, and I got to tell it which matrix to use. So I actually first have to go into the matrix, edit, and I chose matrix A. And remember, it's going to be a 3 by 4. So just to show you how we would set this up in the calculator as a matrix, we'd put, that's a 1a plus 1b plus a 0c. There is no c there. Equals 3. A 2a minus 2b. Remember, negative is different than minus, so it's a negative 2 that we're using. Negative 2 plus 1c equals 17. And then we've got 2a. There's no b, so that's got to be plus a 0b, right? So 0 for b minus 2 for c, and it equals 14. Once you go to the catalog and bring up RREF, it starts its own parenthesis, and you're going to tell it which matrix to go to. So you're going to hit matrix, and you're going to select one named A. So let me go to matrix, second matrix, right? And you go to the one named A. So that's going to put in here an A that looks like that. Feel free to close your parenthesis, and it's going to give you an answer. The answer, remember, from Algebra 2, as long as you've got ones in the main diagonal and zeros in the other locations, my calculator is telling me, oops, let me get to that answer again, that I've got 5, -2, and 3. So it gives me this, 5, -2, and 3. That's how it's giving me the answer in the calculator. I believe it also starts with that and that. But here is where we're looking. That's your A, B, and C. So how do we write our final answer out? We go back up to here. A is 5. So we've got 5 over that denominator, x minus 2, plus B is -2x, plus C is 3 over that denominator, x squared plus 2x plus 4. And there is our solution for that one. Again, remember, you're going to be asking questions during video conferencing, through email, or through discussion threads. So feel free to ask questions about this if you got confused, or back up the video. Take a look at it again. Let's take a look at this next one here. This one is only different in that it's got repeating prime quadratics. So remember, a prime quadratic is because we can't factor it. X squared plus 1, it looks like you can factor it. It looks like the difference of two squares, but that's not the difference of two squares. That's the sum of two squares. So we cannot factor this one, at least not in the real number system. Imaginary number system we could, but that's a different day. So anyways, how would we set this one up like this? Well, here's what we're going to do. I'm going to back up a little bit here. I'm going to say it's going to equal, well, now our first denominator is just going to be this to the first power. So x squared plus 1 just one time. That's going to be, since it's quadratic, it's got to be over a linear, like this one. So we're going to say ax plus b, first variable, second variable. Then we're going to add it to the next fraction, which is both of these. So it's going to be x squared plus 1 to the second power. And this is a different numerator, so we've got to go on to the next variables. And it's also got to be a linear numerator, remember. So we're going to go ABCX plus D. And there's our setup there. The rest of it follows exactly like this. We're going to multiply it by the common denominator, x plus 1. Sorry, x squared plus 1 squared. That's going to distribute here, here, and here, which here cancels them both out, leaving us 5x cubed minus 3x squared plus 7x minus 3. Over here, one of them cancels, so we're going to get the ax plus b times one of them, x squared plus 1. And then in this one, they're both going to cancel out. So we're just left with plus cx plus d. So, like I said, this is just following the same pattern as before. We're going to go ahead and multiply these out and simplify. So I'm going to go ahead and leave that for now so we can squish back that way. So that would come down equals, FOIL this, ax times x squared is ax cubed. Ax times 1, I'm going to put that here, plus 1ax. Actually, I didn't need to do that, did I? Let's get rid of that. So plus 1ax. Plus 1ax. Inside, bx squared. And last, plus b. Plus cx plus d. So just like before, now we're going to group the like powers. So there's only one cube, right? So ax cubed. There's only one square, plus bx squared. Now there are two x's, so let's put plus ax plus cx, and there are two constants, plus b plus d. Like so. Now, this all still equals this. Now, let's go ahead and separate this out here so we can see that again. So it still equals the 5x cubed minus 3x squared plus 7x minus 3. And you guessed it, it's exactly what we're going to do. We're going to line things up right now. So notice the x cubed only goes with that part. So this is going to be really helpful in a few moments. We're going to realize that the 5 equals a. Ding, ding, ding. That's already done. Okay, well, what about this part? What about the negative 3 and the x squared? Well, there's only one x squared, b. So, right, we're pretty happy here. Negative 3 equals b. Okay, now we've got a little bit more work to do, but not a big deal. 7 with the x goes with those two parts. So remember what we did? We factored out the x. So this is really a plus c times x. It's like what we had done here or here where we're factoring it out. So a plus c equals 7. So let's go ahead and put that in. A plus c equals 7. We're going to have to work with that one. As well as this next one, when I say the minus 3 equals the b plus the d part. So we're going to write that in. B plus d equals negative 3. Now, in our graphing calculator, we have 4 variables. We have 4 equations. Just to show you, I would rewrite this one here, really. I mean, we know a and b. We can do this without our graphing calculator, can't we? Think about this. Right now, if a is 5, 5 plus what is 7? Well, 5 plus 2 is 7, so we know c is 2. And right here, we already know b. B is negative 3, so negative 3 plus what is negative 3? Negative 3 plus 0. So d would have to equal 0. So there are the 4 solutions. Again, we didn't have to know the graphing calculator for that one. We like that. So let's write out our final answer here. Back up to here. A, B, C, and D. That's what we were looking for. So here's what it looks like. A, 5x plus b, negative 3, over that denominator, x squared plus 1, plus c, which is 2 times x, plus d, which is 0. So I don't really need to put that, do I? I'm just going to put, well, let's put it so we see it. But really, we would just write 2x, wouldn't we? We don't need the 0 there. So we get rid of the 2x. So over that denominator, x squared plus 1. Remember, this is the one that was twice. It was squared. So there's our final answer on that one. So there's partial decomposition, partial fractions when we've got a prime quadratic. We put the numerator as a linear. When we've got repeating prime quadratics, we're going to do the first power, the second power, all the way up to how many powers we've got. The way to solve it's the same with all of them, and we end up using systems of equations. Substitution, elimination, RF, or matrices, whichever way you like for that. Remember your homework now. I'm just going to remind you this. The homework for this section had been to read and take notes on page 832 to 841, problems 1, 9, 17, 21, and 31. And in class problems that we would do to add on to this are numbers 2, 4, 12, 20, and 32. Now, those would be the questions we'd be doing during class, so if you do those now, when we do our conference, our video conference, that would be a great time to ask questions about those. But normally, you would get those that morning before our video conference, so I'm giving you a bunch ahead of days here if you want them. Joke time! Okay, here we go, folks. What did Mars say to Saturn? What did Mars say to Saturn? Give me a ring sometime. Give me a ring.